Hello, everyone. Good evening to all. Hope all of you are doing well and safe. So, welcome to this session. I, Simran Sakla, will be the host for this session, and we have Mr. Mufaddal Masalawala as a speaker with us, who will be sharing his knowledge related to broken access control and its nearabouts. Before that, just wanted to enlighten the agenda. So, agenda for this series of sessions is very simple. We all are aware that due to pandemic, things have gone pretty much virtual. Hence, ISRA, being a non-profit organization, has also decided to take part and provide the security enthusiasts a platform to come together and talk about different topics related to information security. Also, we are overwhelmed with the response we have received for this session, and hence, without any delay, I would like to welcome our speaker for today, Mr. Mufaddal Masalawala. And Mufaddal, over to you.
Thank you, Simran, for the introduction. So I am sharing my screen. Let me know if my screen is visible.
Sure, Mufaddal.
Is it visible now?
Yes, it is. Please proceed.
Okay. So hello everyone. My name is Mufaddal Masalawala. I'm currently working at SecureView Systems as an associate security consultant over here at Pune since past 3 years. I'm keen on learning web application, mobile, and network security concepts. And today I'm going to speak on broken access control and one of its issues, insecure direct object reference IDOR in detail. So I've divided this topic into three sections. First, I will talk about access control, what it is. Then secondly, I will talk about access control, some of its issues of access controls, and then one of its issues, IDOR in detail. So in IDOR, we'll talk about root cause. Why does it occur basically? Then the impact it will have if it's found in any of your applications. Then recon techniques. How do you find for IDOR bugs, common bypasses to IDOR, then the escalation techniques, and then the mitigation strategies to mitigate this vulnerability from your application. So broken access control is at number 5 in the latest current OWASP Top 10 2017 list. Originally, it's a combination of two OWASP Top 10 2013 list, which is insecure direct object reference and missing function level access control. So in broken access control, we also have issues like forced browsing, client-side caching, directory traversal, privilege escalation, and many more. Now, what is access control? So access control or authorization is how a web application gives access to its resources for only some of its users and not everyone. So by resources, I mean two things, sensitive data and sensitive function. So in sensitive data, it comprises of application sensitive data or user sensitive data. And sensitive function is any action that can be performed on web server and the application. So now the authorization checks are performed after authentication function. So as we can see in the image over here, when any visitor visits a web application, the authentication function first comes into picture. Is it asks the user to log in first. Then once the user is logged in, the authorization function checks to what data and function they are allowed in the application. So now according to OWASP, these are some access control issues. So first we'll see forced browsing. Then I'll talk about directory traversal, client-side caching, and then we'll see insecure IDs, that is IDOR in detail. So first, forced browsing. What is forced browsing actually? So forced browsing is an attack wherein the attacker tries to access restricted pages, for example, admin module outside of its correct sequence. So for example, when someone tries to access resources that are not referenced on anywhere on the front end of the application, but the module is still available, accessible to anyone. For example, if the attacker, he or she has the link to it, he can directly access that module over there. So in the scenario over here, we can see that in order to access the internal pages, the admin module, the web application first asks its user to log in first. But if the website is vulnerable, then the attacker can use techniques like directory brute force to enumerate internal resources and directly access them through URL. So directory traversal. When a website stores data in different files, the server might expect a file name as a request parameter. For example, if we have a web module for viewing the GIF images, the URL would look something like this: the load image function, the file name parameter, and then the gift.png value. On the server side, there might be a folder where all the GIF images are stored, and the server looks for that requested name in this folder. So now the attacker can abuse this behavior, as we can see, by giving the dot dot slash etc pass wd or dot dot slash any characters. So what the dot dot slash will eventually do is it will take the attacker to the root directory, and then he can directly access files which he or she desires. Now, in order to defend against this attack, the web server should be configured in such a way that it only has access to the files it requires, none other than the files it does not require then. Also, filtering for dot dot characters should be done over there. So third, we will see what is client-side caching. So browsers store websites in the cache to ensure faster loading if the user revisits the same website again. The interesting part here is the browser may also store sensitive data that was earlier present on the website in its own cache. This might be a problem if multiple people use the same computer. So for what we have in the libraries, the internet cafes, developers should prevent this sensitive caching by using some HTML meta tags. For example, we have cache control header, pragma no cache header, and all sorts of that. Now let's see what IDOR is in brief, like what it is, how it occurs, its implications, and many more in the slides further. So what is IDOR basically? Insecure Direct Object Reference, or simply IDOR, means the application or an API directly uses a reference to an object, something like user details, user files, or anything else which can be directly accessed by anyone or an attacker without any authorization check. So for example, if we have an e-commerce web application which displays the order details just on the basis of the ID parameter and no other authorization check, then any attacker would simply intercept this request and manipulate the parameter to see some other user's details. So for example, we change the ID to 999 from 9876 over here. So the attacker can then get all the sensitive information like address, payment details, contact information, and all sorts of information of that particular user. So this is the basic idea of an IDOR vulnerability. So now what is the root cause? Why does this vulnerability occur at the first place? So let us look at the two code examples here. In the PHP code on the left, we are taking a parameter directly and using it to retrieve users information, which is not the correct way of doing this. So the correct way of doing this is on the code on the right. So a server has to have a session cookie and then look up the user ID in the backend, instead of blindly accepting the whatever sent by the user, what we had seen in the first previous case. Now, in case of serverless architecture, we can also make use of JWTs over there. So now the next one is that the reference to data objects like files or database entries are easily guessable, like having low entropy value. Over here from the example, we can easily predict what the application allocates IDs to its user. So for example, we have the ID 9876. We can easily guess the next ID would be 9877 or 9898 or anything else. And we can directly access that ID value over there. Sorry. So now let's see what impact it has on the web application. IDOR can be very critical or even low depending on what each scenario is. So for example, here we have a delete account request wherein the account ID parameter is sent in get. So now we can see that the account ID is sent in plain. So account ID value is 5679 over here. So attacker can easily intercept this request and change the account ID to some other user like 5699 in this case, and he can directly delete that particular user's account, which would also result into denial of service for that user. Now, instead of a delete account request, we can also have an edit request, wherein we can take over the user's account by changing the login details like password, security questions, and directly gain access to that user's account. Another another critical thing through IDOR is to retrieve sensitive PII information. So for example, I'm testing a web application which has a profile page, okay? So where it shows the profile details of the logged in user. Now what I can do is I can intercept this request, and if no authorization check is performed, then I can directly change the account ID to some other user, and I can see the profile details of that particular user over there. So this is disclosing sensitive information. And we can have many more impacts for the same depending on how the application handles the IDs. So now that we have understood what IDOR is, its root cause, the impact it will have on the web application if it's present. But the question is, how do we find them in any target program? Maybe we are when we are doing some bug bounty or a pen test activity for some company. So how do you find IDORs for over there? Now there are a couple of ways of finding IDOR. This is what I follow. So first, we can make use of certain Google Docs like site target.com in URL ID and then the company name or something. To we can use this Google Docs to check for all URLs having IDs when the search engine may have already indexed, like Google, Yahoo, Bing. Next, we can use param miner, which brute forces common ID parameter names and works. We can also use tools like Wayback URL from Tom Nom Nom, which archives all the links to any web application of the past. And then we can collect all these links and grab for some common ID or URL parameters against those endpoints. So the next one is scrapping JS files. So scrapping JS files is also sometimes useful. We can scrap them for API endpoints with common ID parameters. Since most of us use burp suite during our testing, we can browse the application through burp proxy and then examine the burp history tab to gather endpoints with likely ID parameters. And lastly, we can automate finding IDOR with a burp extension called Autorize. So it's a great plugin which shows you which modules you were not supposed to have access to, but you already did. So it's a great plugin. I would highly recommend everyone to check this out. So now we have found an endpoint with a common ID or parameter in it. So do we directly report it to the program owner? No. There are few checks we should evaluate a finding on first. So first, we should see does the ID belong to a private resource? Like it may be possible that the ID value is open and accessible by everyone, not just you. So double check if it's a private or public resource. So for example, in the example over here, we have a news section, news endpoint. So this is a public resource, but the transaction endpoint, this should be private. You should not be able to see the transaction details of other users. So this is a private resource over here. Next is try to enumerate different possible roles that can be there in an API. For example, the application may also have an admin role. So you currently are on the user role, but the application may also have an admin endpoint, admin role, a moderator role, a super admin role, or something like that. So next we will see the common bypasses for this IDOR vulnerability. Nowadays, a simple IDOR is not usually seen while testing an web application. So therefore, we need to be little creative in order to find one. So these are some common bypasses that I've curated from various helpful blogs and IDOR reports that have been reported in the past on platforms like Bugcrowd, HackerOne. So now the slides are going to be little technical from here on. Okay, so let's start with the first one here. Uh, If no IDs are used in the application by default, try appending common IDO parameters like ID, user ID, a message ID. See if there is any change in the application response. So for example, here we have the two requests. On the upper left is the original default request and its response below it. Then we have the modified request and its response below it. So on the left side is the default get request, which shows your direct conversations messages. So there on the right, what we can do in the same request is we append a user ID and then the 153 or anything value to it, any user's ID over there in the get request, and we get all the messages of that user over you. Next, we will see HTTP parameter pollution. So through HTTP parameter pollution also uh, we can get the IDOR vulnerability. So here the application does not understand that the user is submitting multiple values for the same parameter. But by doing this, we might be able to bypass the access control set on the endpoint. The logic behind this is that the component that performs the authorization check and the endpoint, they both use different libraries to pass query parameters. So in some cases, library 1 would take the first occurrence of the user ID, while the library 2 would take the second occurrence of the user ID. So as we can see in the image over here, we appended an extra parameter, same name, user ID. First, we send the victim ID and then the attacker's ID. We can also do the reverse, first send the attacker's ID and then the victim's ID. Now, this one is little simple. It is not very common, but sometimes requesting a different file type or extension may be enough to bypass the access control. So as we can see, we have a GET request to access the user's data. Now we give the ID 2341 over here, but we get the 401 unauthorized because the access control is properly set over here. So what we do is we change the file type and we appended an extension. Let's say for example JSON 2341.json, and then we get the 200 OK over here. So experiment by appending different file extensions like JSON, XML, config at the end of any request. Now this specific scenario would work if the application is built in Ruby language. Okay. Now in this one, the developers usually leave the non-productive versions of the API vulnerable. By non-productive version, I mean the testing version, the beta version, or the earlier versions of the API would still be vulnerable. So over here we have the API version is version 3, and we are trying to access the user's data endpoint again with the 1234 ID value, and we get the 401 unauthorized because the access control is properly set over here. What we do is we try to access the earlier versions of the API, version 1. And over there, the access control is not properly set, hence we get the user's data over there. Now, if a regular ID replacement isn't working for you, we can try wrapping the ID in an array or a JSON object. So for example, in this one, in the original request on the left, if we try to access the 111 ID, we get the 401 unauthorized because the access control again. But in the same request on the right, we wrap the ID value inside an array and we can bypass and get the results. Similarly, we can also try wrapping an ID with the JSON object as well. Next, we will see about missing function level access control. So many times application have administrative backends which are protected by login functions. One way is through forced browsing that we had already seen in the broken access control issue slides previously. Now, in some cases, these pages are also protected with things like .htaccess or access rule sets that are configured on the server side on the backend. But even there, these files are sometimes misconfigured, not configured properly. So in the example on the left, we can see a GET request to /admin/profile module, which gives us 401 unauthorized because we are not logged in. But if we change the admin word and we change it to uppercase, we might get the access that we needed. We get the 200 OK over here then. So this is another very rare trick, but sometimes this also still works. So in the example, we can see that a GET request to delete a user 1343 does not work. We get the 401 unauthorized. But if we send another request with our own authorized ID with characters, the part traversal technique, and then the ID we want to delete would do us the work. Now, sometimes changing the request method also works for us. So the application will enforce access control only on one HTTP request method. So it will forget to implement the same access control across all the other HTTP request methods. So for example, here we have the post request to delete a user where the user ID is sent in the body. We give any user's ID 165 over here and we get the 401 unauthorized. But if we change the HTTP request method to put and then we replace the same request, we get the 200 OK message. We bypass the access control over there. So if one request method doesn't work, there are plenty of others that we can try instead. We can try get, post, pull, put, delete, patch. So these are also some few things you should also keep in mind while finding for IDOR bugs. So first is whenever we get the encoded or hashed IDs, we should never neglect them. For an encoded ID, it might be possible to decode it using common encoding schemes. And for an hashed ID or randomized ID, say if it is predictable or low in entropy. So in this case, we can try creating multiple accounts and we can analyze how the application is allocating IDs to its user. We can try to analyze the pattern the application allocates IDs to its user. Now, in this particular case, also sometimes the application leaks random IDs in another API endpoint. If we visit a profile page of other user, so we might get an ID in the URL or referrer header or somewhere in the body with an ID or some parameter in it. Second is, let's say a company has a website and a mobile application. So over here, an interesting scenario is the web application might be protected from IDOR, but the same endpoint would not be protected from IDOR. So for example, the web application might be using encoded or hashed IDs, but the mobile application is still using numeric IDs. So we can probe the next ID over there and we can gather the results. So the thing is, you should always check for mobile application as well if that's in scope. Now for the third one, for example, if some endpoint with numeric ID returned us 500 internal server message, okay. So we should try brute force a good range of IDs over there. Like we can try to brute force a range from 100 to 200 or something like that. We can run a script to enumerate 100 values, or we can also make use of burp intruder over there to perform this activity. Next is if an application has an endpoint that receives a non-numeric ID like GUID or an email address, we should try to replace it with numeric value. For example, replace admin@isra.org with the number 100 and check the response over there. Basically, the logic behind this is that there might be multiple ways of referencing objects in the database, and the application may just have access control set on only one of them. Now the next one is simple and little unique. So try to send a wildcard instead of an ID. It's rare, but sometimes this also works. So as we can see, we in the example we replace the user ID with an asterisk. Next is the access control might not be properly implemented for different content types. For example, if your application is sending an XML to the server with the content type header of application XML, so we can change that request and send the JSON to the server by changing the content type to application JSON and check the response with it. Now for the error messages, sometimes application will throw an error message even if the request was executed successfully at the backend. Even if you get an error message like 401 or something 500 error, check manually to see if the application, if the action you performed actually worked or not on the application side or not. Now we'll see about escalation techniques. So IDOR can be escalated or changed to high severity depending on each case scenario. So for example, these are some scenarios that I'll be considering. Uh, if an endpoint has an IDOR with display functionality, we might be able to view messages, sensitive PI information of its users like credit card details, contact information, and much more through just the ID, manipulating the ID parameter. Now, let's say an endpoint performs some action like password reset through an ID. then we would be able to reset someone else's password, login details, and basically take over their whole account. Now, for the last one, let's say uh, you find an IDOR through which you can just change the name of any user in the application. This IDOR in itself would not be a too high impact if you report this one to the program owner, and would just cause a bit of annoyance if exploited. So you won't be getting much more reward for this IDOR. But if you chain this IDOR with a self cross-site scripting, you can use this to deliver the cross-site scripting exploit to code to the victim's browser. You can then perform uh, uh, attacks like redirecting the victim to the some malicious website, steal the sessions, and much more. So this way you can create targeted stored cross-site scripting that requires no user interaction at all. Now, the mitigation strategies is similar to what we had already seen in the root cause slide. For the access control mechanism, it's a vast topic itself, which comprises of different types of access control that can be implemented, like role-based access control and many more. So basically, the idea is that the application should perform an access control check to ensure the user is authorized enough to request the object or a service they are trying to access. Yeah, so that's all from my side. Thank you for listening for me today. I hope you learned something today. So you can also refer to this link for more detailed notes on IDOR. Over here, I'll try to push detailed notes on all vulnerabilities and attacks. Over to you, Simran.
Thank you, Mufaddal, for being such an awesome speaker and helping us understand the concepts in a better way. Now, I would like to request the audience to post their questions in the comment section if anybody has any questions, or you can just turn on your mic and ask simply. Okay, so I'm assuming either Mufaddal has made things for us very clear, or like the audience is hesitating a bit. No worries, we can entertain your questions later also. So you can just contact to Mufaddal if you have any issues or any queries related to IDOR or broken access control. So looks like we are finished with the Q&A as such, and it's time to wrap up the session. So I would like to thank you everyone for taking out time on Saturday and being such a nice audience. Please feel free to reach out to us if you have any queries. And thank you for joining. Have a good day. Thank you, everybody.
Thank you everyone for joining. Have a good day. Bye.